Okay, this is the lecture video for Mat 1100. We're in lesson 3.4, where we're going to be taking a look at solving inequalities as well as graphing them. Okay, in this first example, we see the inequality B is greater than. Remember, the greater quantity sits inside the open part. The pointy part points to the smaller quantity. So this is red. B is greater than 4. So when you go to graph it, all you have to do is put an open circle on 4. If it had a little piece of an equal sign, then I would color this in. Greater than means shade to the right. All the numbers that are greater than 4 are to the right. So you're going to shade to the right. So you would shade this way and color in that arrow, meaning that it goes to infinity. Okay, anything that is given to you like this would be a less than or equal to symbol. So this is red. A is less than or equal to, and I can even write here how do you say it verbally? B is greater than 4. That's how you would say this one verbally. So that just means B can be any value greater than 4. Select the N off of there. Whereas this one means A can be any value less than or equal to negative 4. A is any value less than or equal to negative 4. Okay, that's how you say that verbally. And anytime you have a less than, you will shade all values to the left of the end point. This is called the end or anchor point. It starts off all the values that you're going to talk about. You were trying to talk about, in this particular problem, all values greater than 4, so you shade it to the right. Here you're trying to talk about all numbers that are less than negative 4, and this is where negative 4, so that serves as your anchor point. Because of the equal sign, you will color it in, meaning that actual anchor point belongs to the solutions, and you're going to shade all numbers to the left, because that's the only way that you can move less than a particular number is moving to the left. So anything over here satisfies this requirement, numbers that are less than negative 4. Okay, so greater than, shade to the right. There's no little equal sign. You should have an open endpoint. Less than, shade to the left. And if there is a little piece of an equal sign, the anchor point or endpoint will be colored in. Okay, here we go over the symbols again as we did in a previous section. This is greater than or more than. There are different ways to say greater than. This is just another way to say it. This is another way that you could say less than. This is the symbol for less than. This is greater than or equal to. You already had a summary table in the previously in this chapter where I gave you the meanings of all of these things and went into even more detail than this table. Less than or equal to, and these are just other ways, which again I already went over in a previous section. So it just comes out naturally in this section as well, since we're talking about graphing and solving inequalities. Okay, so let's try to once again take a verbal statement and translate it into a mathematical statement using symbols, numbers, and variables. To be eligible for a senior admission rate, a visitor must not be less than 65 years old. Use Y to represent the age of the visitor who gets the senior rate. Okay, to get a senior rate, you must not be less than 65. So that means you can be 65 or older. That's exactly what this means. If you can't be less than 65, that means you can be 65 or older or greater. So if this stands for the age, you can be greater than or equal to 65 to get a senior rate. Okay, another verbal description here, which again we're going to translate into symbols. An inequality statement. To be eligible for financial aid, a student must earn at most $20,000. To get financial assistance, you can only earn, this is the most you can earn. Okay, so if that's the most you can earn, that means that you can earn $20,000 as your income or less. Because if you earn any more than that, then you are not eligible for the financial aid. 20,000 or less. Okay, use S to represent the yearly earnings in dollars of a student who is eligible for financial aid. So that's the yearly earnings, and it can be $20,000 or less. I'm just reinterpreting that for you so you understand how to state it using inequality symbols. So it can be equal to 20,000 or less than that. This represents the, yearly earnings. Okay, so we did some graphing here. We did some interpreting verbal expressions into symbolic inequalities. And then on this page we have solving inequalities. The only thing that is different between solving an equation and an inequality is that if the last step of your solving process involves either multiplication by a negative or division by a negative. Then you will switch the direction of the inequality. I'm just writing it in my own words because it actually says this down at the bottom of the page. Okay, so here we go. Let's see if we can recognize whether or not this is happening so we know whether we need to switch the direction of the inequality. These are the things that cause the direction to change. And when I say direction, if it's open like this, you would flip it the other way. Okay, so if your last step involves multiplication by a negative or division by a negative, that's when you would switch the direction. Okay, that is not happening here because the one and only step that has to be performed in order to solve this is to get rid of that 7, and then the variable will be isolated because you only work until the variable is by itself. So if this variable is being divided by positive 7, all I have to do is multiply by 7. Well, I'm not multiplying by a negative, so I don't need to switch that direction. Remember, whatever you do to one side, you must also do to the other side. So leave this inequality symbol pointing in the same direction that it is right now at the beginning. These 7s cancel out. and you get W is greater than 35. You can also rewrite this if you want to, which happens to be pretty useful when you're going to graph your solution set if you put the variable first. Just when you rewrite it, make sure that it says the same thing that it says right now. Remember, whatever is sitting in the open, on the open side of the inequality symbol, that is the greater symbol. Just make sure that you're putting your double in the open, on the open side, just like it is now, if you're going to rewrite it like this. Opens to the W, just like this, opens to the W with the little equal sign and then the 35, because it's much easier to read that way, and it's much easier to graph if you have to graph the values that correspond to this. This is red. W is greater than or equal to 35. Okay, solving this problem. If you were going to solve this, you would need to remove the 9 as well as the 4. This whole fraction is a multiplier, and you can get rid of the 9 as well as the 4 by just multiplying by the reciprocal. Notice that I am not multiplying by a negative, so I don't need to worry about switching the direction. I'm simply going to multiply by the reciprocal here, and I always do the same thing on both sides. Okay, so these 4s would cancel because I have a 4 in the denominator as well as the numerator. The 9s cancel for the same reason, leaving me with just a y on the right-hand side. So this is y is less than. Notice that the y is not inside this open part, so that actually, when you're reading these statements to yourself, you always have to read the variable first. That's why I think it's more useful if you learn how to rewrite it with the variable on the left, because then it's hard to get it wrong when you're verbally explaining what it means. On this side, do the calculation. Just top times top, which is -8, bottom times bottom. Okay, if you were to rewrite this, just so you could be more successful at reading it out loud as well as graphing it, it would be y, pointy part going right into the y, and then whatever the value is. When you read this, this is red. Y is less than -8/9. Okay, so moving to the next inequality. Here we have more than one step this time. We have to remove the positive 9, then remove the 2. So we're going to subtract 9 on both sides, just like as if we were doing an equation. Drop down that inequality symbol. The 9 cancels with the -9, leaving you with 2 times v. 4 take away 9 is -5. Go in one more time and try to isolate the v. All I'm doing is dividing by a positive. I am not dividing by a negative. It's only multiplication by a negative or division by a negative on your last step. Well, I'm on my last step right now, and all I'm doing is dividing by a positive, so therefore the direction of this inequality remains the same. Again, I think you should practice the skill of rewriting it, because it's easier to choose a verbal description when they have you verbally explain what your solution means, and it's easier to graph it. So I would put the variable over here, the number over here, rather than the way it's written here. Pointy part goes right into the v, so keep it like that with the equal sign that it has. This is red. V is less than or equal to -5/2. Okay, if you're going to do this problem, I'm going to do this problem in a way that I'll be able to illustrate when and under what circumstances do I switch this. You know you have to get the y's all on one side, and I'm going to just choose to move this 9y over here just so that we get a negative coefficient so that I can illustrate when this switches. Okay, so I'm going to subtract 9y from both sides, and you can not write this and just use the arrow, but do at least show it on the side where you're going to be combining the two terms. So this cancels with this. You no longer have y's on the right-hand side, only a negative 14. And then 6 take away 9 is negative 3 minus 2. And then you're going to add 2, add 2. Keep that symbol the way it is. We're trying to isolate that y. You always get rid of numbers that are added or subtracted to the variable before tackling this coefficient. So I'm adding 2 to both sides to get rid of that. That brings all my constants over here, negative 12, and it leaves me with a negative 3y. Well, at this point, I'm ready to do my last step, and I have to divide to get rid of that. I have to divide by a negative to get rid of that coefficient. So when you are either multiplying by a negative on your last step or dividing by a negative on your last step, which is, I'm doing one of those right now, that's going to cause this thing right here to switch. Okay, so if instead of it pointing like that, it's going to point like this. These negatives cancel, leaving you with just y. Negative divided by negative is positive, and that reads y is greater than or equal to 4. And this is just a recap of what I said up here. Okay, one more problem. We have another application type problem. Pablo has a tree in his backyard. The tree grows 35 centimeters each year. So 35 times the number of years that you're allowing it to grow. Since the tree started growing, Pablo has trimmed off 22 centimeters off of its height. So this is the height that it grows after growing, after a certain number of years. You put the number of years in here. If you're allowing it to grow 1 year, it'd be 1 times 35. If you're allowing it to grow 2 years, it would be 2 times 35. But in any event, 22 centimeters has been chopped off, so it's been brought down by 22. In the end game, considering the height that it experiences per year and also how much has been chopped off it, we want that overall height to be greater than 258 centimeters. Okay, so the first thing it says is solve the given inequality and graph the solution as well on the number line, and also choose and complete the statement that best describes the solution. Okay, so let's see. Let's solve this. If I was going to solve this, I'll do it down here so I have a little bit more room. So 35x minus 22 is greater than 258. Again, we want this overall height to be greater than 258. To solve this, I would have to add 22 on both sides to remove the negative 22. That would leave me with 35x is greater than 280. This plus this is 280. Then if I divide by 35 on both sides, that would give me x is greater than 8. I believe that is. Let me put that in my calculator. 280 divided by 35, yeah, 8. Okay, so let's interpret this. This stands for the number of years you have allowed the tree to grow. So it's going to have to grow for greater than 8 years in order for it to end up, in order for the overall height, which is this expression right here, This is the overall height after you consider how much it grows per year and the fact that 22 centimeters have been taken off of it. We want that overall height to end up being greater than 258, and this solution says that it's going to take greater than 8 years for that to happen. So let's graph that. Greater than 8, open circle on the 8. Numbers that are greater than 8 are over here. Okay, then let's choose a solution that is an interpretation of this scenario and what it means with respect to the original inequality. Okay, so it says, let's see, to meet the goal, the tree must be more than 258 centimeters. This will take less than, that is not the kind of answer we got. We got that it's going to take more than 8 years for this to happen. That's how this is used. Number of years is more than 8. So because they're trying to lead you into this less than a certain number of years, that's what makes this wrong. To meet the goal, the tree must be more than 258 centimeters. So both of these started off right. This one ended wrong, which is why I had to cross this one out. To meet the goal, the tree must be more than 258 centimeters. So that's right. This will take more than, this means more than 8 years. So this one's perfect. What's wrong with the statement down below? To meet the goal, the tree must be less than. No, it isn't. They started off, this inequality started off by saying the overall height is more than 258. So because of this phrase right here, that's what makes this one the wrong choice. Okay, so that's all 3 parts of that particular problem. We solved it, we graphed it, we interpreted it. Okay, that completes section 3.4 lecture.